everybody. My name is Grant Pitarys. I will be walking you through the newest Junior Varsity MECC Excel case, Understanding Your FICO Score. This was the one for the most recent Saturday challenge, and it's on the following theme. Alex is a college senior who dreams of buying a new car after graduation. Before heading to the dealership, Alex wants to understand how a FICO score is calculated and how a higher score means a lower interest rate and lower monthly payment on her car loan. Work through each level to help Alex understand her credit score to figure out how much she can afford. Before we begin, I just want to show that it might be beneficial to expand the formula bar vertically because we will be using multiple lines, and I'll go over how we'll be using those shortly. But in the meantime, let's take a look at the bonus questions. There's 5 here, each relate to levels 1 through 7, so we will need to solve them first. So we will just save these for the end and do the levels first. Let me zoom in a little bit, just in case people need to view the easier. Alright, starting with level 1. After graduation, Alex wants to buy a car and needs a great credit score to get a low interest rate. One key factor is credit utilization, the percentage of a credit limit that is currently being used. Calculate credit card utilization, which is, they give us the formula there, balance divided by the limit for each game based off of the given balances and credit limits. Express credit utilization as a percentage by multiplying the calculation by 100. So they give us the formula, balance divided by limit, and we want it as a percent, so we multiply by 100. So for example 1, we have a $350 balance on a $1,000 credit limit card, and to do that, we do 350 divided by 1,000, multiply it by 100 to get 35. So let's just see if that works here. 350 divided by 1,000, that gives us 0.35, and then wrap it in parentheses, multiply it by 100 to get 35. So that is the answer here. Let's just paste that into here. Drag this down and paste the answers in here. Game 1's answer is between 20 and 24. Game 2's answer is between 30 and 34. And Game 3's answer is between 6 and 10. So they line up with the hints. I think we're pretty confident in our answers here. FICO tip, keep credit utilization as low as possible. Level 2. Going on to level 2, Alex discovers that amounts owed, the total balance across all credit cards, also affects the credit score. The lower the total balance, the better. Calculate total balance across all of Alex's credit cards. So, for example 2, cards with balances $210, $85, and $540 have a total owed of $835. So what's nice is it's wanting us to sum these items here, but what's nice is the sum function doesn't really care if there's blank cells in here. We're still going to get the result like so. So let's just do a sum and throw that in here, and we can drop this down. Let's say that you're an enterprising individual and want to try to get all of these answers in a single formula. In other words, one formula that spills down all the way over here. That is where by row would come in handy. So just to demonstrate, by row, let's select the array. It would be this entire, this entire array. And what function do we want to apply to this row to this array for each row? It would be sum. And you can see we do get the same results. So that's just if you're trying to get one formula to do all of what we just did. But this would do just fine. FICO tip, keeping current on multiple accounts can improve your credit score. That is true. Level 3. Alex learns that lenders often look at the worst card, the one with the highest utilization rate. Calculate the utilization rate across all of Alex's credit cards. Oh, the highest utilization rate. So, example 3. The three cards have utilizations, which remember is balance divided by limit of, this was 45%, that is 22%, this is 68%, and we want to return the highest. So this is the first opportunity for some more advanced tactics. Obviously, we could just calculate each of these individually and take a max, but you notice that they have this specific pattern here. Balance, limit, balance, limit, balance, limit. And just to demonstrate what we're trying to do here to sort of speed up all of these future calculations, is if we have it something like this where, let me just do something manually and show what we're trying to do here, what the end goal is. So those are our balances. The limits are the same, so I'll just do a quick shortcut here. And if I can do this divided by this returns all of the utilization rates for them. And of course, we do have to multiply them by 100, but we can just do 100 times and put that in parentheses, and then return the max of this. So the idea is we would like to get a single column of the balances, a single column of the limits, and then we can just do balance divided by limit to get the rates and take the max of it. So this is where knowledge of indexes will come in, and just to make things a little bit easier, let me put a sequence up here. Sequence, and I'm going to do it for columns. I'm going to do 6 columns. 1, 2, 3, 4, 5, 6. And I'll center these. Let's bold them. You know what, let's just make them bigger too. So you can see that card 1 balance is in index 1, card 2 balance is index 2, and so on. I want to pull out just the balances and get an array. So that involves me taking index 1, 3, and 5. Well, let's just take a look at what index does if I just return column number 1. You'll see I get 450. Let's just do this manually first, and then hopefully you'll catch what I'm trying to get at here. So 1, 3, and 5 returns all the balances that I'm looking for. Well, how can I get 1, 3, and 5? Just, of course I could put these in a curly bracket, and that would do it. Let's say things get even more complicated, and I want more of a formula. Let's say I have like 100 of these. Well, the sequence function, which is what I use to generate this top line, actually scales very well. So what are we concerned with? We would want how many total rows? Well, we have 3 outputs that we're looking for, so our rows will be 3. What is our starting index value going to be? Well, we know it's the balance, so it's going to be 1 here. And what we left off earlier was step, and how do I want my sequence to increment? Well, I want to increment by 2 because we want 1, 3, and 5. And if I add parentheses, because I put my number right here in the rows, it's going to give me 3 rows here, which is actually quite convenient. So that generates all of the balances. If I want to do the same concept but for the limits, uh, the number of rows will be the same. The start is what's going to be different. So rather than starting at index 1, which is a balance, I want to start at index 2, which is card 1's limit. But the step will still be the same. And there we have our balances. So let's put this in a let function just to organize our thoughts a little bit better. And this is why it's useful to expand your formula bar. And just my personal preference for let is to just do equals let, and then do a line break. The way you do a line break is with Alt plus Enter as the shortcut. And let me just create a field for my array. I always start my names with underscores just for posterity. It makes things a lot easier. And name value 1, this is what I'm assigning to the array. It will be this right here. And that's my input. That's my only input. So let me go down here. Next will be balances. So I'll do underscore bals. And I didn't copy the formula, so let me just retype it again. Index array. And I want to sequence 3 rows, start at 1, step is 2. And we're going to do the same thing for limits. This I can copy because I know that my start is the only difference here. Starting at 2. And let's talk about utilization. Util. It's going to be 100 times our vowels divided by... Oh, I did not end the parentheses. I'll do that. There we go. Things look better here. Divided by limits. The balance divided by the limits. And our answer itself is actually going to be the maximum of utils. And we want it to return an answer. And just like that, we have what we're looking for. I can just update my array to be there. And 74 and 81, 77 and 84, 73 and 80. And I actually didn't check for up here, but we can go ahead and take a look. 1050 is between there, 2580 is between there, 790 is between there. So that is how you can use index to basically get every other item from an array. All right, moving on to level 4. Alex's advisor warns that having multiple cards over 40% utilization can seriously hurt a credit score. Count the number of credit cards that have a utilization rate greater than 40%. And it gives us a hint. Consider using count if. So, example 4 tells us that the 5 cards are at 45%, 22%, 68%, 26%, and 86%. That gives 3 cards that exceed 40% utilization, and that would be the answer here. Of course, this is a walkthrough, so I will be showing you how to solve it, but for some strategizing of metagaming, we can see that we're going to have a maximum of 5 and a minimum of 0. So if you just had completely no idea on how to get this answer, you can always guess. 7 points per game is actually pretty good. How do we guess on this? Well, we can do a rand array. How many rows do we want? There's 20 rows here, right? 20 rows. What's the min value that we want for a rand array? That'll be 0. Max is 5. And we do want integer. Oop, I did caps lock here. Integer true. And it's still going to be an array, or since the formula is rand array, I have it set to update every time something new happens. So you just select everything and paste as values. And those are my guesses. Just to be curious, let's see how good those guesses are. I think a little bit more of a metagame would be probably leaving out 0 and 5. It's probably going to be somewhere in the middle. So probably between 1 and 4. But these are our guesses. Let's see how good they are once we actually solve it. So, clear those out. Notice that we do need to calculate utilization across multiple credit cards. And what's nice is the formula up here will scale. We just have to update the array to go across 5 cards. So let's go over to here. The array is instead going to be this entire array. And let's just return util first and get a sense of what we're looking at. Oh, something I need to update here as well. Let's put the sequence up here. Sequence of 10 columns. And again, we'll bold this, we'll center this, increase the size. Notice this is only going to be returning 1, 3, and 5. I need to return 5 of these. 5 items, and 5 items there. And there we go. So the level 4 gives us a helpful hint. Consider using COUNTIF. I think that's valid. Let's just take a look at what using COUNTIF will look like. Here's the range. The criteria, one would think they would enter, oh, just greater than 40. No, we get an error here. And this is what I don't like about COUNTIF, is it's unintuitive. You actually need to put in a quote around greater than 40. That gives us the answer here. And the reason why it's unintuitive is if you were doing an if statement of this being greater than 40, comma, true, comma, false. Yeah. You would notice that I didn't have to put that in quotes, and that's just a restriction that COUNTIF has. What I actually like more, and this is kind of more inefficient because we're using multiple formulas, is using the filter function. So we're filtering this array, and we're only including items from that array that are greater than 40. And how do I know how many items there are? I can wrap that in a rows function. And that just, everything makes more sense in my mind, so that's what my preference is. But if you did want to use COUNTIF, you're more than welcome to approach it that way as well. Greater than 40. And it's not greater than or equal to, strictly greater than per the instructions. So let's just apply that here. Our answer is going to be, the way I see it, rows, filter, util, include util greater than 40, and return my answer. Hopefully we get 3. Perfect. Let's grab that, put that in here, update this to here. Between 1 and 4, 1 and 5, 2 and 6. So that's the case. Let's see how good our guesses were. Equals this, equals this. Did we get anything right? Ooh, we got 1, 2. We got 3 right. 21 points that we wouldn't have otherwise. All right. FICO tip. Try not only to keep your overall credit card utilization low, but also your level of utilization on any one credit card. Uh, just to step out of the game for a second, obviously, if Alex is looking to buy a car, ideally they wouldn't have any balances because they're not carrying any debt. They would be in a better financial picture if they are trying to buy a card. And keeping the utilization low also involves just carrying as little debt as possible. But moving on to level 5, FICO scores are calculated using many different pieces of credit card data in your report, and they give some information here. Credit card data is grouped into 5 categories with different approximate weights: payment history, amounts owed, length of credit history, new credit, and credit mix. Assume that each category has a score that ranges from 0 to 100. FICO scores range from 300 to 850. Note that this is not how FICO scores is actually calculated, but we're just doing an approximation here for this case. To calculate the overall FICO score, Calculate the weighted sum of the scores and multiply the weighted sum by 5.5 and add 300. So the idea is we get the weighted sum multiplied by 5.5 and then add 300. What this means is the minimum score that we can get is 300. Calculate the FICO score based off of the given score data. Round your answer to the nearest integer. So we will be rounding. It says, hint, consider using sum product to sum the score values multiplied by the weights and round to the nearest integer. So they give very clear instructions on what to do here. And for the example, we are doing, here are our weights, here are our values, 88 times 35%, 82 times 30%, and so on. We get this result, 83.5. 83.5 times 5.5 gives us something else, and then we add 300 to get 759.25 and round it to the nearest integer. So, a lot going on here, but the let formula will make things easier. First, let's just do let, and let's define what our weights are. Our weights are these values. Oops, didn't have a comma here. Our weights are these values up here. And since this is a fixed array, I don't want this moving as I move other things around. I'm going to put dollar signs around them. Shortcut here is F4. And what this means is these weights will always be fixed even if I copy the formula down. Similarly, our scores are these values. And I do want this to be relative to where the formula lives because we'll be going down the line. It gives us explicit instructions to get the sum product, so I'll just call this product, and we'll do the sum product of weights and scores. And what else does it want us to do? Well, our answer is going to be the product times 5.5 plus 300. And it also wanted us to round, right, to the nearest integer. So let's wrap that in a round function. 0 for integer. And let's return answer 759. Well, let's copy the formula over so that way we have it here. Drag you down. 711 is between 706 and 715. 669 is between 664 and 673. 768 is between those two. Perfect. So I think this is good to go here. FICO tip, payment history and amounts owed are the two most important categories. That is true. All right, Alex is shopping for car loans and visits several dealerships. Each visit triggers a hard inquiry. However, shopping around doesn't impact the FICO score. All similar inquiries within 45 days are counted as one inquiry. Calculate the new FICO score with one additional inquiry based off of the given current FICO and previous inquiries. Important, current FICO score already includes the reduction caused by previous inquiries, which occurred more than 45 days ago. In the table to the right, FICO reductions due to an inquiry are incremental, i.e. the fourth inquiry reduces the FICO score by 2. So going from a FICO reduction of 8 to a FICO reduction of 10 means there's 2 additional reduction points there. Gives us a hint, consider using XLOOKUP to determine how to reduce the FICO scores, and I think that is a good approach. Example 6. With 3 previous inquiries, 1 new inquiry from any amounts of car loan shopping increases the number of inquiries to 4. 3 and 4 inquiries, it already gave us this right here, or right here, I mean. That 1 new additional inquiry would reduce it by another 2 points. And again, it reiterates what it was discussing over here. So I completely agree with an XLOOKUP solution, and to make our life easier, let's go ahead and assign named ranges to here and the FICO reduction. So the way we can assign a name range is first select the range that we're looking for, go up here to the top left, and just start typing. Like what I do before, I'll start it with an underscore, and let's give it a name. I like to start my arrays with ARRY, and this is just going to be inquiry. How about that? And the way we do in a named range for the FICO reduction is the same way. So underscore ARRY, we'll call this FICO underscore reduct. Your names can be better. I'm just throwing out whatever works here. All right, so now we need to figure out how we can determine not only what the next FICO reduction will be, we also need to know what the previous one was as well. So there's two different ways we can approach this. I like the way that I'll demonstrate because it actually will allow for more flexible uses in the future. So first, let's just figure out what the FICO reduction is for 3. So XLOOKUP, this is the value. Our array is inquiry. Our return array is FICO reduction. And we get 8 there, which we know is the case. Of course, we can copy this and do this plus 1, and we will get the same answer. Or not the same answer, but the answer that we're looking for, because we want to search for the next previous inquiry. Another, just to demonstrate a interesting use case for XLOOKUP, is this match mode item. So the way that this will work is, let's say I add 0.1 here, and you're going to think, well, 3.1 isn't in on this num inquiry list. Match mode we can set to exact match our next largest item, and now it will. So it will see 3.1, it won't find a 3.1, but it will look for 4 there, and 10 gets turned out. But that's just an interesting use case, not necessarily applicable here, but something that XLOOKUP can do. So let's just go back to here. All right, so what are we trying to do? We want this to ideally result in -2, and then add that to 740. So let's do equals this minus this, or other way around, equals 8 minus 10. And add into the FICO, and there we go. To make everything cleaner, let's just put this in a let formula, equals let's current FICO Prev Inc. Here we go here. Let's do, and then we already have the formula for the score, so let's just do ANS, comma, and just a temporary placeholder while I copy our values. Here's our XLOOKUP. So our answer is going to be the first one. Well, just to make everything cleaner for the video, let's well, we'll just do it like this. So this minus this plus 1, and then we're adding back in our current FICO. And again, previous inquiry, 738. Paste that in here, update our inputs. 737 is between those values. 739 is between those, and 758 is between those. Perfect. All right. Last level. Alex is ready to buy. Given a monthly budget and a loan amount and a credit score, find the max car Alex can afford. Use the table to the right to look up the interest rate and the monthly payment per $1,000 borrowed by credit score tier.
Maximum car price is equal to this formula, monthly budget divided by monthly payment per $1,000 times $1,000. Calculate the maximum car price Alex can afford given the monthly budgets and FICO scores. And of course, round to the nearest integer. Again, it gives us a hint of using XLOOKUPs and the round. And there's a lot going on here, but I think the example does a good job demonstrating. A FICO score of 720 corresponds to an interest rate of 6.5%. 720, 6.5%, and a monthly payment of $19.57 per 1,000. A $450 monthly budget coming from here, divided by 19.57 and multiplied by $1,000 gives this 22,000, almost 23,000 figure, which rounds to 22,994. So let's break this down. Again, we need to look up here. So let's assign this a named round, range underscore ARY, FICO score. And we actually don't care about the interest rates. That's just some additional information. What we really care about is the monthly payment. ARY payment. And let's see if we can replicate what's going on. So first we want to XLOOKUP this value on here and return here. We want to take our monthly budget and divide it by that result. And then multiply it by 1,000. Let's do it over here. And then we want to round it to the nearest integer. So that's everything that's going on here. I could, of course, copy this downward, but we can use let to just make this look a little bit cleaner if we're working on more complicated problems. And maybe that's just the first step. So our FICO score is here. Forgot the comma. FICO score is there. Budget is here. And our payment is XLOOKUP. Our FICO score and we want to call this payment per 1K. Our budget, we'll call it total budget, is our budget divided by payment per 1K. And of course, we're going to multiply it by 1,000 and then round it. Round, take that, comma 0. And that's our answer, so I'll just return total budget there. Of course, this is the answer, but this is just demonstrating best practices with let. So let me copy that here. Let is useful if, let's say, our inputs were repeating multiple times throughout the formula itself, and I had to update this a bunch of times. Here I can just drag down one for each one. And 19,960 is between those. 16,099 is between those, and 26,178 is between that as well. Perfect. So, having a high FICO score can save you lots of money when buying a car, house, or other major purchase. All right, so those are the levels complete. Let's head over to the bonus problems. In level 1, if one borrower had all the game's balances and credit limits, excluding the example, what would their total credit utilization be? Sum the balances and divide by the sum of the credit limits and round to the nearest integer. All right, so sum this divided by the sum of that and round to the integer. Seems easy. Let's just get the round one first. Round sum of this divided by sum of the limits and round 0. Oh, and we have to multiply it by 100. Can't forget about that. 30. All right. In level 3, how many individual credit cards across 20 games have a utilization rate greater than 50%? This is level 3, and we care about how many of those cards have greater than 50%. Okay, so let me clear that out of the way. Well, we know what the utils are. Let's go ahead and put this outside here. We're excluding the example, right? Usually we are. Yep. Well, let's just return util first. Here are all our utilizations, and we care about how many are greater than 50. So what we can do instead is, here I will do the countif, just to demonstrate what we can do here. We want to count how many of the utils are greater than 50 and return the answer. What's going on? Count if util greater than 50. That's what I get for trying to use countif here. Countif range. Oh, I know why. Because it's in a let formula. One of the many tricks, things that can trip you up with countif. It actually won't function inside this because we are building util inside of let. So instead we literally have to use, well, this is just my alternative. You have to use an alternative. My alternative is the rows filter util greater than 50. Yep. Many struggles with that. We can add a if empty 0 for posterity. That's not good. I don't want that. Oh, interesting. Okay, let's have that. Let's have that not be there and instead wrap this in an if error. If error. Here, I can just wrap the rows in an if error. If error, this, comma, 0, and parentheses. Why is it? I can just sum this. No need to make this as tricky. Oh my gosh. I want this calc to be 0. But why is it returning 1 here? You can clearly see that this should be 0. If error, value if error 0. This, I did not have this problem on my practice run. Okay. If error this, comma, 0. Sure. Sometimes you have to be flexible with what's going on. And things might not work as expected, so you just have to have a few different solutions to the problems in your knowledge toolkit. We know the answer here is 24. The way I did know that off the cuff is I can highlight this. The status bar on the bottom says 24. Click that to copy it. Very useful. In level 5, what is the median FICO score across all 21 games? Include the example. Okay, so we can use the median function. And let's do a VStack in level 5. So we want to take the median of, I want to take the median of this and the median of all of these. So VStack will turn this into one big array and give me the median of it all. 715 will be the answer here. In level 6, what is the total number of FICO points lost to previous credit inquiries across all 20 games, excluding the example? In level 7, how much more can borrowers with FICO scores of 700 or higher afford versus those with lower FICO scores? The instructions off the bat there left me a little bit of confusion, but they do make it clear of the process that they want. Sum the answers for the high FICO scores greater than or equal to 700. Subtract the sum of the answers for the low scores less than 700. Let's go down to here. So we have our answers for level 7. What we can do is filter our answers, and we want to include values that are greater than or equal to 700. Those are our high scores. We can take the same process and do less than 700. And it gave us the direct instructions. Sum this, take away the sum of this. So equals sum of this minus sum of this. And that is our answer. So how much more money? It's that. It does help that there is 2 more on the high versus low. So with the bonus questions done, we can quickly check our work. And we see that our answers line up. So that is it for the case here. Understanding Your FICO Score JV edition. Thank you very much for watching, and I hope you did just as well on the live case.